Okay, so this video we're going to graph a line from a linear equation in slope-intercept form. So slope-intercept form is this form. So y equals mx plus b, where whatever number is in this position of m, that's your slope, and whatever number is the b here is your y-intercept, or the number or the location where the line crosses the y-axis. This is the y-axis. So here we have the equation. I'll write it right underneath. Y equals 2/5 x plus 2. So we can see that 2/5 will be our slope, and 2 will be our y-intercept, or the point 0, 2. I like to record those, so let's write them down. So our slope is defined as change in y over change in x. So in this case, 2/5, meaning this line's going to go 2 units up and 5 to the right. And our y-intercept is the point 0, 2. 0 because it's on the y-axis, 2 in this number, so 2 up. So the way you do it is you do this first. You need 2 points, basically. You need 2 points. So our first point is easy. We just put a point at our y-intercept. So the first thing is to put a point at your y-intercept. And then we need another point to draw our line. So we don't have another point, but we have the slope. So we'll just count out the slope from this y-intercept, and that'll give us a second point, and we can just draw our line. So again, first plot your y-intercept. First plot your y-intercept. And then use the slope to get another point on your line. So from this point, not from the origin, from the y-intercept, we'll just count out the slope. So that's 2 up. So I count 1, 2 up from the y-intercept, and then 5 to the right. 1, 2, 3, 4, 5. So that's the second point that's on my line. So to be clear, first point, you need 2 points to draw this line at least. First point is the y-intercept, so that's 0, 2 right there. And then from there, I just count out my slope, up 2 over 5, from this point. Up 2 over 5. And that's it. And then you can draw your line. If you have more space, you could do another up 2 over 5 again to get a third point, or on and on, 4 or 5 points. So this is the graph of this linear equation, y equals 2x plus 2. So I'll do one more example. Let me tilt down here. So I'll show you a couple things that can happen here with this example, but the process is the same. So you're in slope-intercept form. This is slope-intercept form. I'll write this right underneath so we can see all the parts and how they work. So whatever the m is, that's your slope, not -7/2 x, but just the -7/2. And then whatever the b is, including that subtraction sign of that negative. So my slope, which is defined change in y over change in x, is -7 over 2, meaning this goes down 7, right 2. And then my y-intercept is whatever that number, the b is. So in this case, -4. Now something interesting is going to happen here that we want to be open to. Here we go. So let's plot our y-intercept. So first plot your y-intercept. So it's 0, -4, meaning 0 to the right. I don't go to the right at all, and I go down 4. So there's my y-intercept. Now, like I said before, now we want to follow the slope to our second point. Now, because of our kind of small coordinate plane here, we don't have space to go down 7. So that maybe you're stuck by that or something. So I want to show you a trick when graphing on the coordinate plane here. So this line is going to extend forever. It has a negative slope, so I know the general shape of this line is going down from left to right. So what I can do is I can do both of these moves in reverse. I can basically go backwards on the line to find a point that came before this. So the way you do that is I do the reverse of both of these things. So I do 7 and negative 2, meaning I go up 7 and I go left 2. Now you really only ever need to do this in this case that I'm showing here, where we run out of space, so we go backwards on the line. So from this point, notice it's the same to go down and right, that'd be some point down here, as it is to go up and back. We can see that makes the same line, right? That line will go down here eventually. So to be clear, if I run out of space, just do both in reverse. Instead of going down right, go up left, and you'll create the same line. So from here, I'm going to count up 7. 1, 2, 3, 4, 5, 6, 7. And not right, but left 2. So we can see this is going to create a line that still goes down from left to right. So to be clear, you don't just change one direction. You don't just go up and right. You have to change both of them. You go, instead of down right, you go up left. And when I draw this line, we can see that it still goes down from left to right. So that negative slope can be a clue to us that we did it correctly. So to sum up, you're in slope-intercept form. Y equals mx plus b. M is the slope, whatever number you see here in front of x, not including x, just the number in front, that's your slope. Change in y, change in x. Whatever's here is your b, that's your y-intercept. See, this number's right there. So I graphed that number, negative 4. And then I tried to do my slope to find the second point, down and to the right, but we ran out of space. So we just go backwards with the slope. We just do both of these, change in y, change in x, in reverse. So I go up and left instead, and it creates the same line. So if I did go down 7, right 2, this line would hit that point. It's kind of off the screen here. And that's it. That's graphing a line from slope-intercept form.